Now to some new pictures that have been released by NASA showing our largest planetary neighbor, Jupiter, in unprecedented detail.
Welcome to our latest YouTube exploration, where we delve into the fascinating realms of space and astronomy. Today, we're discussing an extraordinary event. The James Webb Telescope has just intercepted a huge object heading towards Earth. Join us as we unpack this cosmic mystery and understand its implications. NASA has recently unveiled stunning new images of Jupiter, our solar system's largest planet, captured with remarkable clarity. These images are named in honor of Enrico Fermi, the Italian-American scientist, and they resonate with the Fermi paradox, a concept central to the search for extraterrestrial life. Since the 1950s, this paradox has puzzled scientists, asking why, despite the vast number of planets and stars, we have yet to find evidence of alien life. The James Webb Space Telescope has brought new insights into this question. One of its recent projects involved a simulation where it tracked and analyzed an interstellar object racing towards Earth, providing invaluable data on its composition. This discovery, revealed through the first publicly shown image from the James Webb Telescope, prompts questions about the implications of these findings for the existence of extraterrestrial life. We delve into how the James Webb Telescope's interception of this massive object en route to Earth could be a significant step in our understanding of the cosmos. We also revisit the historic journey of the Galileo spacecraft, launched on October 18, 1989, aboard the Space Shuttle Atlantis from Kennedy Space Center. Destined for Jupiter, Galileo had a unique trajectory, initially moving towards Venus to gain momentum before heading to the outer solar system, a journey that provided us with years of valuable photos and data about Jupiter. As the Galileo spacecraft journeyed towards the Sun, it made a remarkable maneuver, circling Earth twice at altitudes of 597 miles and then 188 miles. This unique path allowed engineers to thoroughly test the craft's sensors. Astronomer Carl Sahn, a member of the Galileo scientific team, termed this maneuver the first flyby ever observed by Earth. This experience prompted him to contemplate what a spacecraft on a quest for intelligent life might discover on a distant planet. Our Earth presented a wealth of observations. The urban sprawl glows with heat islands and flickering lights, painting a picture of a technologically advanced civilization. The ebb and flow of atmospheric gases, marked by rising levels of carbon dioxide and methane, along with industrial waste clouds, indicate intense human activity. Occasional radioactive leaks and a global hum of electromagnetic broadcasts from countless devices and antennas add to this complex tapestry. Such observations led to intriguing questions. Would civilizations on other planets mirror ours in terms of chemical and electromagnetic technosignatures? For decades, the search for extraterrestrial intelligence focused predominantly on radio technologies akin to those developed by humans. Early scholarly articles from the late 1950s even speculated about the potential for interstellar communication with these hypothetical beings. Until recently, such investigations might have seemed fruitless. However, a series of advancements has reinvigorated the search for technosignatures. Key among these is the discovery of exoplanets orbiting distant stars, made possible by breakthroughs in astronomy and more sophisticated telescopes. These discoveries have significantly expanded our understanding of potential life-bearing planets and opened new avenues in the quest for extraterrestrial intelligence. The number of known exoplanets is soaring, with NASA's count reaching 5,084 as of August. It's becoming increasingly clear that most stars in the sky host at least one planet, a realization that has only taken root in the last decade. Considering there are an estimated 100 billion galaxies in the universe and about 100 billion stars in our own Milky Way, the potential for life and advanced civilizations seems almost boundless. Our capabilities in space exploration are advancing rapidly. The unveiling of the initial images from the James Webb Space Telescope last summer marked a significant leap forward. This, along with numerous other sophisticated ground and space-based instruments in development, is revolutionizing our ability to observe distant cosmic objects. We're now entering an era where exploring planetary atmospheres and detecting subtle signals has become possible, thanks to tools like the James Webb Space Telescope. A prime example of these advancements was the spectacular panorama of cosmic cliffs, composed of gas and dust, stretching 24 trillion miles high, featured in NASA's first release of images from the Webb telescope. These images unveil distant cosmos regions with unprecedented clarity and beauty, offering both stunning visuals and puzzling mysteries. The James Webb Space Telescope stands as the most distant and historically significant telescope ever built, capturing light from stars over 13 billion years old. As we continue to receive images and data from the Webb telescope, which can observe both distant and nearby cosmic phenomena, we must be ready to encounter and interpret sights previously unimaginable. The telescope's unique capability to peer across vast cosmic distances and time itself is not just expanding our knowledge of the universe, but also challenging our understanding of it. The James Webb Space Telescope, equipped with advanced infrared sensors, is poised to study the atmospheres of nearby planets such as Jupiter and Mars, as well as Earth-sized exoplanets orbiting distant stars. A prime target is the TRAPPIST-1 system, located 40 light-years away, which hosts several Earth-like planets. A key objective in observing these planets is to identify biosignatures, or signs of life. On Earth, biosignatures can be anything from clamshells and bird feathers to fossilized ferns and sedimentary rocks. Similarly, certain ratios of planetary gases like oxygen, methane, water, and carbon dioxide might hint at the presence of life on other planets. The search for these biosignatures, along with technosignatures, is a pivotal part of astrobiological research. A recent observation using the James Webb Space Telescope showcased its remarkable sensitivity. While analyzing a known space rock in the main asteroid belt, the telescope unexpectedly detected a much smaller asteroid, potentially the tiniest object Webb has observed to date. This discovery, made from over 72 million miles away, reveals the telescope's impressive capability in infrared astronomy. The asteroid, estimated to be between 300 to 650 feet in size, roughly comparable to an aerial football field, demonstrates that Webb's mid-infrared instrument could be instrumental in future asteroid detection, a role not originally intended for it. This finding was communicated by NASA using an illustration rather than a photograph, which led to some confusion and disappointment. However, the serendipitous detection of such a small, faint object in images intended for another purpose underscores the remarkable potential of the Webb telescope in unveiling the universe's secrets. In the midst of a visually overwhelming cosmos, distinguishing the tiny dot of an asteroid amidst the millions orbiting the Sun is a formidable challenge. These space pebbles, primarily found in the main asteroid belt, a donut-shaped region between Mars and Jupiter, are numerous. But the smaller asteroids have often been overlooked by scientists due to their elusive nature. Lying almost parallel to Earth's orbit around the Sun, the main belt has been a recent focus for the James Webb Space Telescope. Early measurements aimed at this plane revealed that even brief observations in this region inevitably capture some asteroids, most of which remain unidentified. This accidental discovery has opened new avenues for exploring these lesser-known celestial bodies. Researchers are now keen to devise strategies for intercepting extrasolar objects that pass through our solar system. Spacecraft equipped to pursue these galactic wanderers and capture images from a few hundred miles away could shed light on their composition, history, and origins beyond our solar neighborhood. This pursuit gained momentum 6 years ago with the discovery of the first known interstellar visitor, Oumuamua, a mysterious 300-foot wide object that traversed the solar system in October 2017. Oumuamua's uniqueness and enigmatic behavior, particularly its unexplained acceleration, posed a puzzle for scientists. Its unexpected speed boost and other peculiar characteristics have sparked intense interest and speculation about the nature of such interstellar objects. Among the various theories proposed by scientists to explain the mystery of Oumuamua, the speculation by renowned Harvard astronomer Avi Loeb stands out. He hypothesized that the object might be a piece of extraterrestrial technology. Had a mission been ready to intercept Oumuamua 6 years ago, we might have unraveled some of its enigmatic aspects and origins. In anticipation of future encounters with similar interstellar objects, scientists are now developing a spacecraft designed to remain on standby until it's needed to chase down such a target. This proactive approach aims to ensure that we don't miss another chance to investigate an object as peculiar as Oumuamua. Under the guidance of Amir Siraj, a team of experts has been formulating the logistics for such a mission, including the timeline, spacecraft velocity, and the ideal distance for a flyby. However, there's been some disagreement among scientists regarding Loeb's theories about Oumuamua and the 2014 meteor being artificial. The lack of conclusive evidence has sparked debates on how to differentiate between natural and man-made interstellar objects. Siraj and his colleagues are exploring techniques to identify such distinctions. They posit that materials of extraterrestrial manufacture might exhibit spectral characteristics markedly different from both naturally occurring substances and human-made synthetics. While the primary aim of the European Space Agency's Comet Interceptor mission is to meet with a pristine comet in the outer regions of our solar system, the spacecraft currently being developed and set to station at Lagrange Point 2 might also be repurposed for an interstellar pursuit. This flexibility adds an intriguing dimension to the mission, potentially extending its scope beyond the initial goal. In ASA, scientists are currently conceptualizing the bridge to the STARS expedition, aimed at intercepting an interstellar object in the future. Such an official interstellar intercept mission would offer a rare chance to study an extrasolar object up close. As the Large Synoptic Survey Telescope, LSST, and other cutting-edge observatories continue their search, the catalog of identified interstellar objects is expected to expand. This will help determine whether Oumuamua was an anomaly or if the galaxy is teeming with similar objects. Meanwhile, the James Webb Space Telescope, JWST, has made a discovery that could unravel a major cosmological puzzle. It has observed early galaxies filled with luminous gas clouds, shining more brightly than their nascent stars. These galaxies appear to have formed just 500 million years after the Big Bang, glowing at unexpectedly high levels. This challenges the traditional cosmological paradigm, which suggests that the earliest stars slowly formed from materials condensed a few million years post-Big Bang. Normally, only galaxies as star-rich as the Milky Way could exhibit such luminosity, but these early galaxies achieved this brightness in a much shorter time frame. This revelation poses a significant challenge to our understanding of galaxy formation and development. However, astronomers using the JWST have now proposed a potential explanation. They've identified a cluster of galaxies about 12 billion years old, with nearly 90% of them shrouded in. Researchers have made a groundbreaking discovery using the James Webb Space Telescope, JWST, revealing that glowing gas clouds in early galaxies played a crucial role in rapid star formation. This gas, heated by the light of nearby stars and subsequently cooling, sparked bursts of star formation, contributing to the larger size of these early galaxies. The Advanced Deep Extragalactic Survey, utilizing 3 instruments on the JWST, analyzed the spectra of galaxies, uncovering the presence of these brilliant gas clouds. When observing the frequencies of galactic light, the team noted spikes of extreme emission features, indicating that the gas was absorbing light from nearby stars and re-emitting it. While gas alone cannot produce light, it becomes excited by radiation from young, massive stars, which were abundant in early galaxies. Interestingly, almost 1% of the emission spectra observed were akin to those found in more recent galaxies in the universe, which are more straightforward to study. This similarity offers hope that understanding these later galaxies will provide insights into the earliest galaxies and the chemical makeup of the early cosmos. Besides hydrogen and helium, all elements in the cosmos, including those that make up Earth, originated in the cores of ancient stars. Therefore, understanding the early universe's conditions around stars and galaxies is key to comprehending our current cosmic environment. In another discovery, the JWST has revealed that WASP-17b, a distant gas giant planet, possesses a silicate-rich, extremely hot atmosphere. This planet experiences winds at thousands of miles per hour, propelling small quartz crystals through its atmosphere. The presence of aerosols in such extreme conditions further. Recent observations have led to fascinating insights into the atmosphere of WASP-17b, a remarkable exoplanet. While the Hubble Space Telescope had previously predicted aerosols contributing to clouds or haze in WASP-17b's atmosphere, the discovery that these aerosols are composed of quartz was unexpected. WASP-17b is a remarkable planet, boasting an extremely high dayside temperature of about 2700 F. This is largely due to its close orbit around its host star, completing a revolution every 3.7 days at a mere distance of 4.9 million miles. Situated 1,300 light-years from Earth, WASP-17b's inflated atmosphere has resulted in it being one of the puffiest planets known, with a diameter roughly 50% larger than Jupiter's. The James Webb Space Telescope has targeted WASP-17b for its unique characteristics. Observations suggest that the planet's composition is primarily hydrogen and helium, similar to Jupiter. Additionally, traces of water vapor, carbon dioxide, and the distinctive absorption signature of pristine quartz crystals, measuring at 8.6 microns, have been detected. These quartz particles, as small as 10 nanometers and resembling Earth's hexagonal prisms, add a new dimension to our understanding of exoplanetary atmospheres. Silicate minerals, including quartz, are rich in silica and oxygen. Although silicates have been previously detected in the atmospheres of hot Jupiter exoplanets and are a common component of all rocky bodies in our solar system, the simplicity of the quartz in WASP-17b's atmosphere is intriguing. Prior expectations leaned towards more complex silicate forms like olivine and pyroxene, rich in magnesium and mercury. However, the quartz crystals observed could represent the initial stages of silicate grain formation, serving as seed particles for the larger, more complex silicates found in cooler exoplanets and brown dwarfs. WASP-17b, a tidally locked gas giant, always presents the same face to its star. This unique orientation leads to the formation of high-altitude hazes, essentially diffused clouds of rock crystals, near the planet's day-night terminator zone. These hazes, carrying quartz nanoparticles, are whisked around the planet by winds. Upon reaching the day side, they evaporate due to intense heat. Remarkably, the pressure at the altitude where these quartz crystals form on WASP-17b is just a fraction of what we experience on Earth, and the crystals form directly from gas without transitioning through a liquid phase, despite the planet's high temperatures. In another intriguing development, scientists may have solved a long-standing mystery surrounding the first super-Earth ever discovered. This bizarre world is known for its extreme volcanic activity, which contributes to the formation of an atmosphere that is subsequently stripped away, leaving the planet barren. The James Webb Space Telescope is set to observe this peculiar exoplanet to test this theory. Discovered in 2004 and located about 40 light-years from Earth, the rocky planet 55 Cantry E is about 8 times the size of Earth. Its proximity to its parent star, at less than 2% of the Earth-Sun distance, results in a mere 17-hour orbit, exposing it to extreme conditions. This proximity has led to some of the planet's peculiar characteristics that have baffled scientists. One of the most enigmatic aspects of 55 Cancri E is its transit signal. From Earth, we can observe this light when the planet transits across its star, creating a small eclipse, and when it passes behind its star. The light output from 55 Cancri E varies significantly during these events, sometimes appearing completely dark and at other times unusually bright. The fluctuation in its visible light output remains one of the many mysteries that continue to intrigue astronomers. The Spitzer Space Telescope's observations of 55 Cancri E have revealed that, while the infrared signal from the planet is consistent, its dayside experiences extreme temperatures exceeding 4,400 F, in stark contrast to its somewhat cooler yet still blistering night side at around 260 F. Recent studies suggest that 55 Cancri E's proximity to its star may be causing significant outgassing. This process, potentially fueled by massive volcanoes and thermal vents, releases carbon-rich gases into space. However, the planet's atmosphere struggles to endure the intense heat, and over time, the gases are stripped away, leaving the planet barren until outgassing resumes. This cycle results in an atmosphere that fluctuates between presence and absence, possibly explaining the planet's unusual transit signals. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q and a sessions with experts. Your membership will grant you the chance to participate in live Q and a sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.